Hello everyone, welcome back to my channel AI Shorts. So this can be like a bit lengthy video. I will try to wrap it up as soon as possible. So yeah, in this particular video we will see how to do RAG. RAG is retrieval augmented generation on audio files using LangChain and Python. So we see the response that the language model generates, and then we see the source files that were passed into the language model as a context, and when it was generating the response basically. So retrieval augmented generation or RAG is a way to enhance the transparency and the relevance of the language model responses. So we do this by supplying the language model, so with the documents that are relevant to our query. So that is what will generate the response. So we'll be combining several technologies to do this. So first we will use assembly AI to transcribe the audio files, because language models can only process the textual data. So next we will use the Hugging Face to embed these documents. So these embeddings are numerical vector representations of the documents and that capture their meaning. So next we will use the vector database Chroma, if you see here. So Chroma is used to store these embeddings. So this vector database is actually make it easy to perform a similarity search, so that we can extract the documents that are relevant to our query. So finally we will pass the retrieved documents as a additional context when we require OpenAI's GPT model. So when we query the OpenAI's GPT model, we will use LangChain to tie these all pieces together. So we are importing dot environment here. So the dot environment, like in Retrieval QA chain, chat OpenAI model, assembly AI, audio transcript loader, Hugging Face embeddings. So in this dot environment, we can use dot environment dot load underscore dot environment. So this is what actually loads the environment variables from .env file. So it consists of the API keys for example OpenAI and assembly AI API, which we are using. So next we will specify the audio files that we are going to use for the RAG. So we will just specify these in the list. These are the URLs to remote audio files. So we will use the assembly AI document loader to load these audio files as a text, but this loader can only handle one audio file at the time currently. So we will write a short function to loop through each file, if you see here. So and append this result to a list. So depending on the length of these audio files, they might be take a little while to transcribe. So usually they will take around 15 to 20% of the length of the audio file. So during the retrieval, we will search our vector database for relevant documents, then pass them in as additional context. It's going to pass in the entire document that's deemed to be relevant to the question. So what we are going to do now is like split up our transcripts. We can just select out the relevant chunks of the text, because if we have a transcript of 1 hour audio file, then it's unlikely that entire hour is going to be relevant to our question, because you character text splitter, and we define a chunk size and chunk overlap. So the chunk size just determines how much big each chunk of this transcript is, and then chunk overlap of 0 just means that these are non-overlapping pieces. Next we actually do is the splitting by calling the split underscore documents method of the text splitter. So we pass in our documents, we are going to get back the text. So we are just split the documents. For each of these text, we set its metadata to be the audio URL, which we are setting it here, of the file which it originates. So now it's time to embed our text. So we can create a function make underscore embed that returns a Hugging Face embedding object, and we don't want to normalize this embedding. So now we we create our Chroma database by feeding in our text along with the embedder, along with this embedder to the Chroma. Now we're gonna use this function to create an embedder and create our Chroma database by feeding it in our text along with this embedder. So we will build the Chroma database using our text we passed in, and the embeddings will be created embed object that we just. If you see here now it's actually time to create the question and answer chain. So that pulls all these pieces together. So that's we actually use when we are querying our model. So we create this make underscore QA underscore chain function. What this does is returns a retrieval QA chain. So we pass in the model. We want an answer chain that pulls all these pieces together So what we actually use is we are querying the model. So we create this make underscore QA underscore chain. What this does is it returns a retrieval QA chain. We just pass in the model that we want to use the retrieval, which is just the database. So this is what retrieves the actual documents, and we specify the search type query, which is which is MMR, which is nothing but maximal marginal relevance. So then we specify what we want to fetch the three most relevant documents. So finally we just specify here what we want to return here and source documents when we query the chain. So now if you see here, it's actually time to write the main loop of our code. So we create an instance of QA chain, and then we create a while loop. First we get an input from the user. This will just be the question that they ask, that they want to ask a QA chain. So we give them the option to break out of the loop if they want to end the program. Next all we have to do is perform a simple pass to this question into our QA chain. Then we can print the results. So we'll print out the question to the terminal, and then we also print out the response of the QA chain. So hope you understand this RAG approach to get the answers for the queries using the large language models and the retrieval augmented generation. If you like my video, please like and subscribe. Thank you so much.